So now we are going to discuss about the equilibrium, write the heading, equilibrium of charges and system of charges and system of charges. Well, these two looks very much similar that we are talking about the charges only. But when we talk about the charge, I'm talking about the individual charge. And when I say a system of charge, then we talk about a system which consists of multiple charges. And in this lesson, we are going to discuss about the equilibrium of those things. Well, we need to understand that for the equilibrium, the net force upon the charge or the net force on the system of charge should be zero. So we can have two kinds of equilibrium budget. So equilibrium could be defined as we've studied in class 11th. We have studied stable equilibrium, unstable equilibrium, neutral equilibrium. अगर आपको याद होगा तो हमने वो सारी बातें करी थी. Now the equilibrium in our syllabus could be translatory. It could be translatory equilibrium, or it could be rotatory equilibrium. A rotatory equilibrium. And in the chapter rotation, we have discussed the rotatory equilibrium in deeper detail. So for the translatory equilibrium, my dear kids, the net force on that should be zero, be it a charge or be it any body. And for the rotatory equilibrium, the net torque upon that particular body has to be zero. So these are the two types of equilibrium which could be discussed, and the conditions for these two equilibrium one by one are given, that the net force should be zero and the net torque should be zero. Now if I discuss about the equilibrium of the charge in detail, in particular, थोड़ा समझना उसको, equilibrium of charge. It means I'm discussing about the one individual charge, one particular charge. That means the net force on that particular charge should be zero. And when I say force, that has to be the vector. It means the vector sum of all the forces acting upon that particular charges should be zero. And when I discuss about the equilibrium of system, I want all of you to note down the way I'm writing. The equilibrium of system, that means forces on each charges should be zero. That means net force, I would say, net force would be a better word, बच्चों. सभी charges पे net force should be zero. Net force on each charges should be zero. It's very important to understand the difference between the equilibrium of charge and the equilibrium of the system. There are going to be a lot of questions that you will see, you will come across on these two concepts. As of now, any doubt, anyone?
No, sir.
Cool.
No, sir.
Great. Now let us do an example. Once you note it down, to understand this properly. Okay, what is essential meaning of equilibrium of charge and equilibrium of the system? Okay, let us say, my dear kids, we have a square with a very fundamental example. And this is the common example. Let's suppose we have placed charges Q, Q, Q on all the vertices. You may name these vertices. Let's suppose this is A, this is B, well, this is C, and this is D. I also place one of the charge at the center. Center is the point where the diagonals intersect. Is the point where the diagonals intersect. Let us have a charge placed over here, and we may say that is, let's suppose, capital Q. All good? Now the question to you, which they can ask you, probably the first thing what they can ask you, find the value of Q so that Q is in equilibrium. So that the Q is in equilibrium. Well, this is the example one. Can someone tell me what should be the value of Q? Of course, for that we have to solve, Hari, we have to solve that, isn't it?
Yes, sir.
Alright then, let me tell you one thing. In the previous classes, I have taught you that if the charges are symmetrically present, symmetrically, then the force, net force on the geometrical center is zero. If you remember, if, note down, agar yaad nahi to likh lo, if charges are symmetrically placed, previous class में मैंने बताया था, symmetrically placed, then the net force at the geometrical center is zero. अगर आपको याद हो So I can quickly tell that no matter whatever the value of charge I put over here, I know that the net force at this point is going to be 0. So Q का value कुछ भी हो 1, 2, 3, 5, 5,000 or 5 lakhs, so does it make any sense to me? Does it matter to me? Of course not. Which means for all the values of Q, this Q which is placed at the center should be in equilibrium. Do all of you agree with me? Yes or no? Quickly.
Yes, sir.
That's all. That's all. Now the second question what they can ask you, which you need to understand, is what should be the value? This is an important question. What should be so this was dealing with the equilibrium of a charge. Now let us deal with the equilibrium of the system, my dear kids. So what should be the value of Q for which entire system of charges are in equilibrium. ये अच्छा क्वेश्चन है, आप इसको पहले लिख लो. Then we are going to discuss this question. What should be the value of Q for which all the charges has to be in equilibrium? One thing I have just taught you, that for the equilibrium of a system, because when talking about the system, net force on all the charges, net force on each charges should be 0. Each charges should be 0 for the system to be in equilibrium. So we can, and we have a lot of symmetricity over here. So let us consider one of the charge and make the forces equals to 0 over there, and then job will be done. As simple as that. So let us say I'm considering this charge at D. The forces on D will be because of all these charges, and we're going to use the principle of superposition to find the net force, because by the principle of superposition, what do we know is the net forces acting on the charge is going to be the vector sum of those forces. So the net force acting upon the charge would be the vector sum of the forces acted by the individual charges. My dear kids, let us understand this. Because of this charge Q at A, there are going to be force in this direction. I believe all of you okay with this. Also, due to the charge at C, there are going to be force in this direction. I'm using the both representing by the same color because both of them going to have equal forces, equal value. So let us say that is F1. So F1 is the charge force on the charge at charge Q at D because of A and C respectively. Also, there going to be a force because of the charge at B, and that should be in this direction. So let us say this is the force due to the charge at B. So let me say FB, the force on the charge Q due to the charge at B. And third and the very important point, my dear kids, F1 and F2 are both equal and they are at right angle. So the resultant of F1 and F2 should be in this direction along the FB itself. All of you agree with me? Quickly respond.
Yes, sir.
And that is, let's say, F2. So the net force acting on this charge in this direction is going to be, let us say, F, in this direction is going to be how much? FB plus F of 2. All good? If I want to have this charge at equilibrium, that clearly means, my dear kids, the net force acting upon this charge has to be 0. Well, that is only going to be possible if this charge Q applies a force on this charge in this direction, and that should be equal to the magnitude of FB plus F2. इसको मान लो कुछ भी F dash मान लो. So there should be a force in this direction that should be equals to F dash. Now that brings us one conclusion, quick conclusion, that Q is a negative charge. Q has to be a negative charge or else we cannot have a force of attraction. And now, my dear kids, for equilibrium, F dash should be equals to F of B plus F of 2. Already I've written, but just for your understanding, I'm writing this. Is that clear to all of you as of now? Any doubts?
No, sir.
Fantastic.
No, sir.
All right, then let me make some space over here, and here we have, So okay, now the next part is just the pure calculations. Let us find the value of F1, F2, and everything else. So the value of F, my dear kids, is going to be how much? KQ, because here we have Q only, upon Q square upon this length is, okay, let's say this side length is A, KQ upon A square. So resultant of F1, this is your F1, this is your F1, resultant of F1, and F1 is how much? F2 we have taken. That implies that F2 could be equals to how much? F2 could be equals to root 2 times of F1. Do I have to do it again, or like you guys are okay with this? 90 degree, you know? All good?
Yes, sir.
That should be root 2 times of kq square upon a square. Chalo, equation 1 we have got. I've got the value of this one, the yellow one, the yellow F2. FB, let us figure out the value of FB. FB is the force due to the charge at Q at B. This length, my dear kids, is how much? Root 2 times of A. जो length है, that is root 2 times of A. We already know diagonal of a square. So the force is going to be how much? KQ square upon root A square. That is going to be KQ square upon A square into 2, which is nothing but half of this force. I mean like half of the F1 force. But anyways, रहने दो, क्या फर्क पड़ता अपन को, है ना? So this is your equation 2. So the net force, which is F dash, if I'm talking about in this direction, due to the B and due to these two, that is going to be how much? FB plus your F2. F2 we have found from here. FB we have found here. So that is going to be root 2. You can take KQ square upon A square plus KQ square upon 2A square. You can take out KQ square upon A square common, and you will be getting root 2 times 2 root 2 plus 1 upon 2. And if you remember, my dear kids, we had done in the previous class, we had deduced this one. So that is why I've told you that time कि अगर याद रह जाए तो कोई दिक्कत नहीं है. You can just remember this. For at the charge on the vertex of a square, the net force upon that by the remaining 3 charges could be easily found out as kq square upon a square into root 2 root 2 plus 1 upon 2. ये बहुत बेसिक चीज है, इसको याद कर लो तो you can save your time while doing the calculations. क्योंकि अगर आपको याद होता है ये वाला पार्ट तो मैं डायरेक्टली यहाँ पे कहानी खत्म कर देता, है ना? डायरेक्टली वी कुड हैव डन इट. चलिए, बट एनीवेज आप इसको जल्दी से नोट कर लो. Now, due to the force on, the force due to capital Q, force due to capital Q. So you can see that this length is how much? Root 2a. So this length, my dear kids, is gonna be a upon root 2. So the force on this charge due to the capital Q should be F dash we have taken. That should be in this direction, and that is going to be how much? So that is F dash we have taken. That is going to be K Q capital Q upon a upon root 2 whole square. That is nothing but 2 times of k q capital Q upon a square, and that should be equal to this one. That should be equal to this one for the equilibrium. So let us equate that, and that was how much? K q q upon a square 2 root 2 plus 1 upon 2. That is going to be equals to 2k cube. And here we don't have q, here we have kq square. Okay, my bad. So just a second, my dear kids. Here we just had q square, not the capital Q was not involved in that calculation. So here we had q square. Okay, now it is good. So 2kq capital Q upon this a square. I can see some cancellations would take place here. The k and this square will be gone. K and this will be gone. A square should be gone. And I know the capital Q has to be negative in charge. It has to be negative. So I can simply say that capital Q, my dear kids, is going to be 2 should come this side, and that's going to be 1 upon 4. And this Q is already here, so Q upon 4. And root 2 plus 1. And if I talk about the sign, it has to be negative. So that is your final answer, my dear kids. That is your final answer. All good?
Yes.
All right then, note it down. So what I wanted to say कि if you would have remembered the force on one of the charge kept at one of the vertex because of the other charge, अगर इसको याद कर लो आप तो that is equals to how much? kq square upon a square 2 root 2 plus 1 upon 2. Then see, in one step we could have done the question. If you are aware of this thing, तो directly इस step से हम लोग शुरुआत करते हैं, यहाँ से शुरुआत करते हैं, इनफैक्ट सॉरी यहाँ से शुरुआत करते हैं और एक लाइन में आंसर आ जाता. तो कोई नहीं, इट जस्ट स्टार्टिंग, अब धीरे धीरे सारे बातें आपके दिमाग में बैठ जाएगी. इफ यू कुड रिमेंबर दिस, हमारा कहानी ऐसे ही खत्म हो जाएगा. चलिए इसको नोट कर लो, फिर आगे बढ़ेंगे. All right, now let us see one question where we can have situations like this. So let's say I have four charges being placed on the sides of a square. This is a square, let's say, and I'm trying to draw the diagram from the side view. So this is my square on which we have four charges. Let's say small q, 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 and the q. One of the charge of value capital Q is placed at a certain height right above the center of it. At a certain height, let's suppose h. I have placed a charge just above its center. The value of Q, charge is Q, and its mass is, let's suppose, m. Its mass is m. The mass of this charge is m. Let the side length be a for apple, a for apple, a for apple. Given that this charge is in equilibrium, it is not falling down. This capital Q is in equilibrium, it is not falling down. So you have to find the value of Q, find the value of Q so that it is in equilibrium, it remains in equilibrium. It remains in equilibrium. It is not falling down, वो गिर नहीं रहा है. आपको इसका वैल्यू निकालना है बच्चों. Well, if you go by the basic method से करोगे तो बहुत टाइम लग जाएगा. You have to deduce each and everything. But now, since that you guys have understood that concept, कि if you place at let's suppose this is the geometrical center, है ना, this is your geometrical center, and इसके ऊपर किसी हाइट h पर रखा हुआ है, तो अपने को पता है बच्चों कि इस पे एक नेट फोर्स लग रहा होगा ऊपर की तरफ, और उसका फॉर्मूले हमको अच्छे से पता है. So in this particular case, we have four charges, 1, 2, 3, 4. So the net force, let's suppose this is the force F. F should be how much? Who will tell me? बताओ तो F का वैल्यू क्या होगा जी?
KQ square by A square.
इल्ले because of all these four, and it is placed at the vertical, ऊपर रखा हुआ है, इसके सेंटर के ऊपर रखा हुआ है. 4 K cube, अच्छा,
KQ by that one.
4 K cube H over here upon the radius of the symmetricity. इसको आप एक symmetrical arrangement मान लो ना. Take this as a symmetrical arrangement, right? Rahul, could you follow what I'm saying?
Yes, sir.
And this radius is going to be this, half of the diagonal. Half of the diagonal radius is going to be half of the diagonal, which is going to be 2 root 2a upon 2. So that is going to be a upon root 2. So this is going to be how much? A upon root 2 whole square plus h square to the power of
3 by 2.
3 by 2. Well, that is the force acting upon this charge in the upward direction. Also, its gravitational weight, its weight of the charge should be acting downward, क्योंकि mass दे रखा है, that is mg. And if it is in equilibrium, for charge q in equilibrium, we know that force should be equals to mg. बस क्या, कहानी खत्म हो गया अब तो. So what is the value of force? We have got it. We're gonna just make it equals to mg. तो बच्चों 4k cube h into capital Q. Why 4? Because we have 4 symmetrical charges placed, ना? And if you simplify this out, या फिर रहने दो इसको ऐसे ही, that is going to be how much? A square upon 2 plus h square to the power of 3 by 2. That is going to be equals to mg. So you just have to, you need to write the value of q in terms of everything else. Game over. So the value of q should be, so कितना आसानी से बन गया ना, mg 4q should come down, तो क्या हो गया, the value of q should be 4k cube h into a square upon 2 plus h square to the power of 3 by 2. बस क्या हो गया, है ना जी, all of you?
Yes, sir.
So if you know this concept, very good. If you know this concept, your job would be easy. और अगर नहीं पता थोड़ा सा मुश्किल डेफिनेटली यू विल बी फेसिंग थ्रू. तो कितना आसानी से ये हमने क्वेश्चंस को कर लिया, मुश्किल नहीं था. जल्दी से फटाफट नोट करो, फिर हम लोग और आगे बढ़ेंगे और कुछ सीखेंगे आज. तो कुछ चीजें आपको याद रखनी होगी टू शॉर्टन योर टाइम ड्यूरेशन ऑफ क्वेश्चन सॉल्विंग, वरना फिर तो यू वुड हैव डन इसका फोर्स निकालो, इसका निकालो, उसका निकालो, इसका निकालो, फिर रिजल्टेंट निकालो, फिर इक्वेट करो. हम क्यों ही लाइफ का लंका लगाए, मेरे पास सब कुछ है ही तो, है ना. आई नो दिस ऑल स्टफ, तो क्यों परेशानी करें. अनिका, हाँ बोलो हरी.
Can you tell why are we equating it to mg again?
Because mg is pulling it down. The only one force which is downward is mg, na? If suppose if mg wasn't there, then this force could have taken this, brought this charge capital Q into a certain amount of acceleration. So this should have gone up, but it is given that it is in equilibrium, which means this F has to be counted or by the mg, or mg has to be counted by F, and for equilibrium both of them has to be equal. That is why I'm equating this with mg. All good, Hari?
So in the previous questions which we did, like which had the same concept,
Mm-hmm.
why we didn't equal to mg that time?
Because that time we were only supposed to find the force, and even if in this question they would have asked you to just to find the force, we could have done that. But now I'm saying that is in equilibrium, it is not moving, because you know that if you apply force on any body, the body would accelerate, right, if it is free to move. So the force will be remaining same, that is not a problem, we don't have to equate with mg. But since we are saying that it is in equilibrium, which means it is not moving, it means this force is not able to create a motion, which means there must be something countering it, and that is mg. So that's the reason why I equated this to mg. All good now?
Okay, sir. Yes, sir.
Fantastic. All right then, you guys have noted it down. Can we go to the next problem?
Yes, sir.
Cool. Okay, let us see one question where you can have some, let's suppose here we have a pendulum, or you can not pendulum, you can say we have two charged particles hanging with equal length of threads of equal length. Let's suppose this is L, normal representation, and they are having some charges and some masses, because we know that charge cannot exist without mass. So let's suppose both have charge Q, both are having charge Q and mass M. Both the charges are having charge Q and mass M, and let us say both are of same nature. Let's say both are positive, both are positive charge, both are positive charge, and this is your, let's suppose, the vertical thing. So since both of them are positive charge, the angles should be, okay, let me make it more central, center, okay. So this is theta, and this also is going to be theta. You have to find the value of theta, and the charges are in equilibrium. Both charges are in equilibrium. Find the value of theta. Find the value of theta. Find the value of theta. That is the question to you. Find the value of theta. Not on the question. So both the charges are in equilibrium, and we have to find the value of theta for that equilibrium situation, equilibrium condition, my dear kids. All right then, let us understand a couple of things quickly. There are going to be weight that should be acting upon both the charges, of course, because they have masses, and that should be downward. Now the another force that should be acting upon these two charges is going to be electrostatic forces, and these two will repel each other because both of them are of same nature. So let's suppose there's going to be force on this, and there's going to be force on this, and of course there should be tension in this string, tension T. Distance between them we can easily find in terms of L and theta. These two forces will have a resultant force, my dear kids. There should be some resultant force, and that resultant is going to counter the tension. There should be some resultant force acting upon this, like this way, and that is going to counter the tension. So this is the electrostatic force, and this is your mg, and this is the resultant. Let's suppose this is the resultant. We know that the net force on this has to be 0. Solution: for the charge to be in equilibrium, for the charge to be in equilibrium, charge to be in equilibrium, net force should be 0. और आपको ये बात पता होना चाहिए कि लेट अस सपोज अगर किसी पॉइंट पे 3 फोर्सेस आर एक्टिंग इन दिस वे, लेट्स सपोज, देन द वेक्टर सम ऑफ ऑल देम हैज टू बी 0. ओके, थोड़ा सा इसको और अच्छे से कर ले, वर्टिकल डाउनवर्ड, बिकॉज द वेट इज एक्टिंग डाउनवर्ड, है ना, द वेट इज एक्टिंग डाउनवर्ड. So let's suppose these are the 3 forces, my dear kids. So the vector sum of these should be 0. So clear cut meaning है कि resultant of these two should be this direction, which should be equal to this. Agree, all of you?
Yes. Yes, sir.
That means tension should be equals to Fr, just for your understanding. ठीक है, मेरे को उससे मतलब नहीं है, but if they ask you to find the tension, you can easily find this out quite easily. What they have asked to us is the theta. Okay, if it is theta, I believe you would agree that this angle should also be theta. These two parallel transversal, है ना? To find tan theta, let's suppose to find tan of theta, what do we need? Tan theta should be electrostatic force by mg. कहानी खत्म, by mg. Now what you have to do is you have to find the value of electrostatic force, and for that you have to know this distance. You have to know this distance. Well, okay, we can easily do that. Look into this triangle. Sin theta, if I do use sin theta, my dear kids, sin theta, if I use, let me write it here. Sin theta should be how much? Let this distance be कुछ भी r ले लो, ठीक है? Sin theta should be r upon l. So r should be how much? L sin theta. This is r, even this is going to be r by the symmetricity. So the distance between these two charges has to be 2r. So let the distance is going to be 2r. Now that we have the distance, we can easily find the electrostatic force. That is going to be k q square upon this distance, which is a 2r. R is L sin theta to 2L sin theta whole square. That is going to be k q square upon 4L square sin square theta. So that is your electrostatic force. mg we know. So बच्चों, tan of theta could easily be written as k q square upon 4L square sin square theta, this electrostatic force by mg, so let me write mg here, है ना? So theta should be how much? I believe you know how to write this. mg will come here, है ना? So you can simply write theta is equals to tan inverse of kq square upon mg times of 4L square sin square theta. Do all of you agree with me?
Yes, sir. Yes, sir.
That's it. And just keep this thing in mind. For these things you can easily find. And if they would have asked you to find the tension, okay, tension should have been equals to how much? The resultant force. Resultant we could have found. if मैं एक line लिख देता हूँ यहाँ पे, F resultant is going to be vector sum of electrostatic force, so Fe square plus mg square. That's it. That could have been the value of tension. पूछा नहीं है, बट फिर भी अगर पूछ दे तो अपने को पता होना चाहिए, कोई पंगे वाली बात नहीं है. चलो इसको जल्दी से नोट कर लो, फिर आगे बढ़ेंगे. Because here both the charges are equal. There could be situations when the charges are not equal. उनका value अलग हो, उनका masses अलग हो. So that is the situation which we are going to discuss now. Please note it down. Now case 2. When the masses and the charges are different. When mass and charges are different. Very important condition, ठीक है? You guys should understand this carefully. Now let's say we have different masses, different charges. So here is the situation. Let me have the diagram here. This is the mean line, you know. As we know that the masses are different, of course the angles should also be different. So because the force of repulsion will be different. Length also could be different. Length भी different मान लो. Length को भी different मान सकते हो, completely upon you. चलो इसको मान लो L1, इसको मान लो L2. Over here, the charge is having q1 and m1, and this charge is having magnitude q2 and mass m2. Obviously, this angle will be different to this angle. Let's keep the charges being horizontal only. The charges still in the horizontal level. We can make it inclined भी हो सकता है, उस पर हम लोग बाद में चर्चा करेंगे. अभी simple रखते हैं. This line is horizontal. Now that we have these things, they may ask you to find a relation between theta 1 and theta 2. Find a relation between theta 1 and theta 2, and they would give certain condition that q1 is more or q2 is more or m1 is more. ये सारे कंडीशन आपको दिए रहेंगे, तो मैं आपको जनरलाइज पूरा सिखा देता हूँ, ठीक है. बाकी जो भी होगा आप उसको इजिली यू कैन फिगर इट आउट. अब ध्यान से समझना मेरी बात को. एट इक्विलिब्रियम, at or in equilibrium, at equilibrium we know that net force is going to be zero. Net force should be zero. तो फोर्सेस देख लो, किसी एक चार्ज पे इसमें फोर्स देख लो. एक तो इसका वेट रहेगा mg डाउनवर्ड, एंड द सेकंड फोर्स माय डियर किड्स विल बी द इलेक्ट्रोस्टैटिक फोर्स बिकॉज ऑफ दीस टू. And electrostatic force on this also is going to be same thing. So let's suppose this is the electrostatic force. Over here is F2 or Fe मान लो, and this is your M1G. This is your M1G. Net force on these two, should be in this direction. And let's say this angle is theta. This angle is theta. And let's suppose this is the F resultant. My dear kids, we know that tan theta, we have seen in the previous question, tan theta is going to be electrostatic force upon mg. In general, we know that. अब ध्यान से मेरी बात सुनना, ओके, लिसन टू मी केयरफुली. पहला केस मान लो, if m1 is more than m2, if m1 is more than m2, and here also we'll be having forces of electrostatic that is going to be equal, that is not going to be different. We'll be having m2g, and the resultant would be here. The resultant would be, let's suppose here, F resultant, this is theta 1 and this is going to be theta 2. So if I write the value for tan theta 1, चलो लिख लेते हैं, tan theta 1 should be Fe upon m1g, and tan of theta 2 should be electrostatic force upon m2g. F is going to be same because equal and opposite है. If m1 is more than m2, that implies that tan of theta 1 should be lesser than tan of theta 2. All of you agree with me? Let me know. ध्यान से देखो. Good. Yes, Rahul, all good?
Yes.
That implies that theta 1 should be less than theta 2. So this is the relation between theta 1 and theta 2 with this condition, m1 being more than m2. अगर m1 ज़्यादा है तो theta 1 कम होगा compared to theta 2. Likewise, my dear kids, इसको पर लिख लो. And then second case is, what if m1 is lesser than m2? अगर ऐसा कुछ है, that implies that tan of theta 1 is going to be more than tan of theta 2, and that implies that theta 1 is going to be more than theta 2. Well, these are the two conditions and conclusions based upon the masses, है ना, and their charges. So this is a good understanding, good example. You should understand this properly. There are going to be good questions that you may come across based upon these things. पूछा जाता है और पूछा जा चुका है. I'm going to discuss some questions on that. चलो नोट कर लो इसको जल्दी से. Done? All good?
Yes.
And noted बच्चे?
Yes, sir.
Okay. One more case. When this entire set of charge arrangement is accelerated, मान लो कि these all things were kept in the lift. This entire arrangement is kept in a lift. It is kept in a lift. and we have the charges like this, and ठीक है, इसको रख लो, कोई दिक्कत नहीं है. Over here, if the lift is, let's suppose, going upward with certain acceleration, let's suppose a, or it may come downward also, कुछ भी हो सकता है दोनों के cases में. If it is going upward, then you need to understand that there going to be pseudo force, and the net force acting downward should be mg plus ma. If you're watching it from the lift frame, electrostatic force will remain irrelevant because charge does not depend upon the frame. Already we know that. So in this case, theta, if I'm supposed to find, then bachcho, tan of theta should be given as force of electrostatic upon m of g plus a. That should be the value of theta. That should be the value of theta. Or and if it is if the lift is coming down, if accelerating downward with certain acceleration a, in that case, I'm just drawing one diagram here. The pseudo force is going to act upward direction, so there is going to be pseudo force ma. Electrostatic force will remain there, that is not a problem. Mg should be downward, and of course here we have the tension on all. So this is going to be theta. So in this case, my dear kids, tan of theta should be given as your electrostatic force Fe upon m times of g minus a. Provided, very important, provided a has to be lesser than g. अगर a g से कम है तो a condition होगा, but there could be case that if a becomes more than g, that could also be the possibilities. तो ध्यान से सोच के देखो, अगर a ज्यादा हो जाएगा, if the lift is coming downward with an acceleration a, and given that a is more than g, फिर क्या होगा बच्चों? What's going to happen to the theta, to this entire set of arrangement? So since a, the pseudo force becomes more than the weight, ये पूरा का पूरा ऊपर चला जाएगा और ये चिपक जाएगा वॉल से, to the wall of the lift. A special case है, if a is more than capital G, then this is going to be situations, my dear kids. ये जो both the charges are going to stick to the wall or roof of the lift, and the angle between them becomes 180 degree. So theta becomes 180 degree. Do you agree with me, all of you? Let me know.
Yes.
Great. Other people, all good?
So the group,
Yes. For example, Hari, let's suppose you are in the lift. Just imagine those Hollywood movies, and suddenly lift start going for free fall. What's going to happen? More than free fall, not just free fall. The lift starts accelerating downward with a value more than g. Then you will be lifted up. आप जाके lift में सर टकरा जाएगा, right? Dup, isn't it?
yes, sir.
So these charges are not gonna be in this format. Tension would become zero क्योंकि ये force ज़्यादा हो गया है mg से, तो ऊपर की तरफ lift करके यहाँ चिपक जाएगा, ऐसे चिपक जाएगा ना जी? Yes sir, no, Hari?
Yes, sir.
So the angle will become how much? 180 degree. Well, guys, this brings us to the end of the Coulomb's law in the normal form. I mean, like in the magnitude form. Going forward, we have to study the Coulomb's law in the vector format. We will discuss the.
Sir, can you put the previous slide one?
Yeah, why not? Okay, here we have. Here you go.
Yes, sir, got it.
Great. So now we're going to study the vector Coulomb's law in the vector form in the next part. All good, bachcho?